So I'm going to continue rolling with the train theme that Kyle introduced. He introduced release trains. I want to start by describing a situation that we've all been familiar with, which is spending lots of time in our basement working on model trains. And so we start off with a basic model train in our basement, and it's great. And it's probably pretty simple, not too many geographic features or vehicles, people, etc. There's no general store. And then we decide we want to add a lot more interest and flavor to our model train. So we go to the hobby store and we bring back a bunch of, a big bag of stuff that we're really excited to build into the model train in our basement that we've been working on for several weekends. So we may set up a water tower and so forth, but we're down there for a while, and eventually we're getting to the point where it's not obvious where everything should go. And time passes, and if someone were to come by and say, look at this model train, they may see that the train kind of leaves the mountain only to turn right back around and come back into the mountain, that there's a cow glued to the water tower. There's just lots of glue everywhere and not very good ventilation in the basement. And this is a problem. We've all been there. And I'm Alan from the Register team. And so what I want to talk about is keeping this from happening with our view controllers. But the view controller issue is something we've probably all seen in iOS apps. We've all come across iOS apps that have these pretty massive view controllers. And we had the opportunity to try something a little different with some work we were doing to customize a build for large sellers. So what I want to do is talk about that, but a better takeaway is that if you do these things to make the view controller smaller, you'll also have a much more testable app. And you'll have a data flow that maybe is easier to reason about. But the view controller thing is something that everyone understands too. So there's different interpretations of what model view controller is. There's a Cocoa flavor of it. And oftentimes, people come away from the Cocoa description of what model view controller is knowing about the three layers. You have a model, you have a view. It's pretty obvious what goes in the model and what goes in the view. The view is just everything that's user-facing. The model is all your state, especially your persisted state. And that kind of leaves the view controllers or the coordinator layer or the controller layer just to coordinate everything. And that's a lot of responsibility for a single layer of your app. And oftentimes, the result will be code that's hard to test because it's unorganized, and anyone who comes into the code base later might have a hard time kind of piecing apart what everything is. So really, you can get to a place where your code is more easily tested by having view controllers that are smaller. And you can end up with data that's much simpler to reason about. So let's just go ahead right into another metaphor here. So here we have architecture design, which is the lasso that we're going to use to wrestle this runaway view controller pig, or calf. It's just a silhouette, so I'm not sure. And then we have a couple of ranchers riding on a horse named Xcode, and they're in grave danger because of that. So let's talk about how we dramatically reined in these view controllers and how we arrived at a much more testable architecture. And even better, how it was easier for beginners to just jump in and understand what's going on. So this is an idea that we're going to borrow from a talk by Andy Matuszak, where he talked about having a one-way flow of data. And it's also part of ideas that were gaining momentum around the time that React was being developed and brought to iOS. But we wanted to have this in our app, and this was before React was public, so we did our own interpretation of it based on the talks. So we agree that having a two-way data flow in your app, especially when it's managed by the view controllers, leads to code that's much more difficult to test and reason about. And like the train, when it's all just going in a simple form, it's pretty easy to figure out what's going on. But start throwing in a bunch of intersecting trains and UFOs and things like that, and it becomes pretty complicated to reason about the state of your app. So instead, we'll move to a one-way data flow. A little bit different. There's some new constructs here, and so what I need to do now is go through each one of these constructs just to explain what their role is. So on the far right, there's the one-way data flow that flows from the service. It flows into the presenter transforms it into a view model, and then we end up with data that's pushed into a view controller. And we have a renderer class, which is responsible for coordinating all of this. So now I'm just going to step through and explain what is going on at each layer. And I'm going to show real-world code snippets, but very abbreviated code snippets. So we have at the base level the service, which is responsible for mutating state. And this is the only place in the app where state is mutated, which makes things a lot simpler because all the heavy lifting is done at the service level. And in addition, it has no knowledge about what's going on in the UI. So you can test these in a headless way. So you don't need to think about setting up all these views and setting up user interaction and buttons and things like that. You can just run these services by themselves, and that will have all the backing for what your app should be representing. So here's an example of a service. This is a cart service. And the actual state that it's storing is that first private instance variable called cart. And as a snippet, I've included the code that you would use to add a discount. And it's only passed in as a string. Now, when it's added to the data model, the discount is not represented as a string. It's represented as an object. But it's the cart's responsibility to do all the parsing, the validation, and to mutate the state. Then, further, it sets the state of the app to no longer need to be in the mode where we're editing a discount. Finally, this call to render signals that we have an update ready. But render itself doesn't interact with any UI elements. It's completely separate. OK, so next we have a presenter. The presenter is what queries the service to get information about the state of the app and transforms it into the view model layer that a view controller can easily consume. So the presenters are arranged as trees, kind of in the same way that views are arranged as trees. And in fact, our view model output is also in the form of a tree. So here's an example of a presenter. Well, first of all, we have the cart view model, which is defined alongside the presenter because they're closely related. So we have a simple struct, and it has a title and a price. And for our view controllers, that's going to be enough for us to display what the discount is. And the struct also has a list of discounts that are just these line items of title and price. So the cart presenter takes one of those cart objects that we saw earlier, which is, at this point is immutable. Now that it's left the service, you can no longer modify it. Nothing else has a reference that's going to mutate it out from under you. And it produces a cart view model. So that's a presenter layer. The renderer is what coordinates all of these things, and it calls on the presenters to produce a new view model. And then it's pushed to the view controllers. So this is a very abbreviated renderer, and it starts with a root presenter that produces a root view model. And then we're going to push the view model into our root view controller, and that'll cause a cascading set of updates. And we already saw what a view model is. It's just a simple bag of values that's immutable, very simple, and it's easy for a view controller to deal with. And the view controller, which was the hook of this talk, it's the thing that we're trying to cut down in scope and size. And really all it's doing now is it's updating its views when it's told to do so. So here's another real-world example of a view controller that no longer has to figure out if you're in the state of editing a discount or not. It's simply told that you're no longer editing the discount, and if so, it dismisses a modal or not, or it presents it. So this is less logic and state for the view controller to have to worry about. All right, so this slide is kind of complicated. I don't know if I'll go through the whole thing, but it's meant to show the entire flow from the view layer to the service layer, renderer, presenter, and view. So this is for adding a discount. And on the far left, we're in the view layer. We're editing the discount. We descend into the service layer. We mutate our state. And then the renderer picks up a signal, and it calls present on the root view presenter. Now we're in the presenter layer, and the presenter will produce a new view model, which will take us back again to the view layer, where we can dismiss that modal that I was showing you. So this is an entire rendering pipeline from view to service to render to presenter to view again. Or in a more simplified form, it looks like this. We have a renderer that coordinates data flowing from the service to the presenter to the view model to the view controller. And each arrow here is kind of a seam that we can use to get in and test each individual layer, which now has more distinct responsibilities, and it has less responsibility than a single monolithic view controller that would do all of this. So a common problem that you might see in some apps is that view controllers end up being this catch-all. When you have only 3 layers to work with, it can seem like there's not necessarily a great place to put something, so it might end up in the view controller, just for lack of a better place sometimes. Whether that's localization or networking or some I/O code, even just implementing delegates, that can end up intertwined in your view controller, and it can lead to something that, again, can be kind of a tangle, and it can be hard to test. So something we've seen, but if you have a different approach to your architecture, the view controller will hopefully not end up in this state. Another problem that we've seen is that view controllers know too much about the persistence level, or the persistence layer, and you have to keep the persistence layer in its cage. And this is something that Andy Matischak talked about. Again, if you have an NS managed object, that is something that can be mutated out from under you. It may be still faulted to disk, and now the view controller has to know about that. So instead, once you leave the service layer, nothing should be mutable at that point. Everything should be available, and hopefully it's vastly simplified by pulling out the fields that you need into a struct and leaving the rest behind in the services view of it. All right, so what should your view controllers do? They should not do that much. They should manage your views and your user interactions. They should push out any real interesting logic to some other layer, which we now have defined what each one is more responsible for. And so hopefully there's a home for it there. And they can have some basic validation. For example, there's nothing wrong with, say, enabling a button when you have some input. But that shouldn't be very complicated, and even better, it's easy to test because your view controller can be brought to life easily, and you can test it just by passing a view model into it. So that's it. I'm Alan Fineberg, and up next is Michael Tarasso.